Hello champion, I'm teacher Adam. Welcome to my math class. Today we're going to talk about the unit of direct proportion and indirect proportion. We will first start by learning what is, we'll start by first learning what is proportion, and then later on look at how proportion is divided into two. One, we have direct proportion, and two, we have inversely proportion. And normally, when we're talking about proportion, it means you are going to talk about quantities. How quantities are being shared between two people. Like you have quantity A and B, and how are they related? Now, in this case of proportion, we are basically going to talk about the variables. Variables, we know we have two variables. We have variable 1, which is x, and variable 2, which is y. The x variable is always, in the Cartesian plane, we're talking about the horizontal line. The y variable, we're talking about all changes that are going to take place on the y-axis. All the changes that are going to take place on the x-axis are on the horizontal line. Very good. So the first thing that we need to know, what is proportion? Because we are talking about proportion. Proportion. A portion is like a share, a selection, a section. That's a portion. Now we're talking about proportion. We say proportion is a way of talking about how two variables are related to each other. Proportion is a relationship between two variables. That can be our number one thing. And then we can say we have types of proportion. So we have types. We have types of proportion. We have types of proportion. A, we have direct. We have direct proportion, and B, we have inverse. We have inverse. We have inverse proportion. So what do we understand by the term direct proportion? So we're going to start with that. For direct proportion, that means that as one variable goes up, the other goes up by the same factor. So this means for direct proportion, we say this is when if one variable changes, also the other variable will change. If one increases by 1, we call it direct proportion. Say means that as one variable change, the other variable change by the same factor. Yeah, so that's it. So you say here, the ratio between the two quantities will always stay the same, because if one reduces by a half, the other one will also reduce by a half. So this is called direct proportion. Correct. And what does it, the symbol, how do we show this is a direct? For example, we say x is directly proportion to, we show this symbol, is directly proportional to y. So that's proportional to, or directly proportional to. So this can be, we say x is directly, how do you read that? We say x is directly proportional to y. Correct. X is directly proportional to y. Y is directly proportional to x. So we can say, if you say y is directly proportional to x, you can as well say y is directly proportional to x. Wow, that's fine. Okay, so what happens if x and y are directly proportional? If x and y are directly proportional. So I would basically show you a different view. We say if the value of two variables are always in the same ratio, so if the values of the two variables are always in the same ratio, the variable are said to be in direct proportion. If the variables are p and q, you write this as p and q. So for example, we say, so if the values of two variables for direct proportion, now extended notes now. We have extended notes that I'm going to give you in this unit. This is my view. Extended note. We say if the values of two variables are always in the same ratio, So if the values of two variables are always in the same ratio, the variables are said to be in direct proportion. So you can look in our previous, say x is directly proportional to. That means for any increase, for any change in x, there is also a change in y with the same factor. This is what it means. If the values of two variables are always in the same ratio, the variables are said to be in direct proportion. Then we say if the variables are, for example, if the variables are p, let one variable be p and q. Therefore, we say, so if, and then we say, so you say P is directly proportional to Q. We say, you will say P is directly proportional to Q. What does it mean? This is read as P is directly proportional to Q. Yes, P is directly proportional to Q. And what does it mean? So first of all, these two quantities cannot be the same. P is not equal to Q. P can only be equal to Q if Q is multiplied by a specific factor. That's why you introduce constant K, or you can call it constant T. You can name it, but there should be a factor that should be multiplied to Q so that P can be equal to Q. That's the thing. So we say P is the proportion to Q means that P divided by Q is equal to constant. So we cannot say P is equal to Q. It can never be equal. But the only way that P can be equal to Q is by you introducing constant K. We need to introduce constant K to say these two quantities are equal, P and Q. So that means we say P is directly proportional to Q means that P divided by Q is a constant. So what does it mean? Here now we introduce constant K. That means if you introduce and that is now P is equal to KQ. And obviously now to get Q is the same as P, because now you have P is equal to KQ. So to get Q is the same as P divided by Q, which is that one. We have to introduce constant K in every situation. How? Let's see what the notes from other books say. For example, y is directly proportional to x if x is 2 and y is 8. What will be the value of y when x is 6? Correct. This is a very good example. Y is directly proportional to x. If x is 2 and y is 8, what will be the value of y when x is 6? This is a good example. The first thing that we understand is say y is directly proportional to x. So you say y is directly proportional to x. Correct. Then we say when we cannot say y is equal to, for us to say y is equal to x, what do? We introduce constant K. So that's the first step. First step, we know what the question is. This is direct proportion. For any change in y, there is a change on x. Therefore, you say y is equal to kx. Are we together? Introduce constant. For you to equate to say introduce constant K. Then say if x is 2, y is 8. So 8 is equal to k times 2. So divide by 2, and then simplify, k will be equal to 4. After doing that, you write, you replace, where there is k, replace in the formula. So you say y is equal to 4x, because k is being replaced in the formula. The formula was y is equal to kx. So where there is k, put 4. Then they say find, the question says find y when x is 6. This is so super easy. So where find y, the formula is this 4x, so 4 times 6. So y will be equal to 24. This is how you solve this kind of question. This is how we solve these kind of questions. Very simple. They will bring these kind of questions, and they want us to be challenged. But normally they're super easy. Super easy. Now, I've just given an example of direct proportion. Then what we do, B. The B is say inverse. The inverse proportion. The inverse proportion, what does it mean? The inverse proportion. So for inverse proportion, it's quite different. What are we supposed to talk about the inverse proportion? The inverse proportion, we say, as one variable is increasing, the other variable is reducing. That's what it means. If one variable is increasing, another variable is decreasing. If another variable is decreasing, the other one is increasing. That's what we say with inverse proportion. We say, if the product of the values of two variables is constant, the variable are said to be inversely proportional. If the variables are p and q, you say q is equal to k. Where k is a constant, this means that p is inversely proportional to q. How do we understand that? So we say, if I go back to the notes, let me check here. We say inverse proportion means as one variable goes up, the other goes down by the same factor. If two quantities are inversely proportional, then we can say that one is directly proportional to the reciprocal of the other. Yeah, so how? So we say, maybe you say, if y is a variable, so y is inversely proportional to, inversely means the fraction of the other. We say if two quantities are inversely proportional, then we can say that one is directly proportional to the reciprocal of the other. So the reciprocal of y is 1 over y. So you see, is the same as what we represent here. So y is inversely proportional to the reciprocal. Reciprocal is the reciprocal of 2 is 1 over 2. So in this case, the same you will follow the step. For you to say y is equal to 1 over x, we have to introduce constant k, and they say y is equal to k times 1 over x. And therefore you say y is equal to k over x. Then make, to get k in this case, cross multiply, you say xy. This is the k. After getting k, you continue and solve the other questions. So it's as simple as it is. So let me get one example so that I may solve and we may be on the same page. Y is inversely proportional to x when x is equal to 8, y is 24. Find y when x is equal to 9. Correct. So y is inversely proportional to x. So that's it. Y is inversely proportional to x. So find, so then you say introduce constant k. Y is equal to k over x. K times x is k over x. To get k, so what do we say? Say when x is 8, y is 24. So when x is 8, so y is 24 divided by k over x 8. To get k, cross multiply. 24 times 8. What is that? 24 times 8? 192. So our k is 192. Therefore, put it in the formula. Y is 192 over x. Then they say y is inversely proportional to x when x is 8, y is 24. Find y when x is 9. So y is equal to 192 divided by 9. So y is 192 divided by 9. You get 64/3. That's the answer. Now let's solve. Now we know what is direct proportion and what is inverse proportion. Let's solve some example. This is another question, example 2. Y is directly proportional to x cubed, and when x is 2, y is equal to 32. A, write this relationship as an equation. Write this as an equation. B, find the value of y when x is equal to 5. To write as and we know in algebra we have two types. We have algebraic equation and we have algebraic expression. An expression is not equated to anything, is not equal to anything. It just represents number. Whenever you see equation, it means you need to have an equal sign. So y is directly proportional to x cubed, and when x is 2, y is 32. Write this relationship as an equation, directly proportional. We say y is directly proportional to x cubed. So write the relationship as an equation. You say introduce constant k, y is equal to kx cubed. This is it. So they say when x is 2, y is 32. When x is 2, y is 32. So what do we do in that case? When x is, so put the numbers. When x is 2, y is 32. Put y 32 is equal to k, x is 2 cubed. 32 is equal to, find constant k. 8, 2 power 3 is 8. Divide by 8. What do we get as k? Say k is equal to 4. Now, go back to our relationship here. Y is equal to kx cubed. Y is equal to, what is our k? We got 4. So 4x cubed. This is the equation they were looking for. And then we say, find the value of y when x is 5. Find the value of y when x is 5. This is simple now. Roman 2, find the value of y when, so y is equal to 4x cubed. So they say find the value of y when x is 5. So when x is 5, what's the value of y? So y is equal to 4, 5 cubed. So y is 4 times 125. So y is equal to 125 times 4, 500. This is the answer. Correct. You get the answer. This is how you do. Let's do another example. This is for inverse proportion. F is inversely proportional to d square, and when d is equal to 3, f is equal to 12. Find the value of f when d is equal to 4. Correct. So f is inversely proportional to d square. Correct. And when d is 3, introduce constant k. Step 1. Step 1 is knowing what was the question, is inversely proportional. Step 2, introduce constant k. So f is equal to k times 1 over d square, which f is equal to k over d square. This is it. Then they say when d is 3, so we know d is 3, and f is 12. So let's find k. Here they say, in other words, you need to find k, the value of k, when you have d is 3 and f is 12. So f is 12 is equal to k over d square, which is 3 square. Therefore, k, you cross multiply. K is equal to 12 times 3 square, which is 9. So k is 108. Refer this. Put it in terms of the number that we've gotten there. So f is equal to 108 over the square. Then they say find the value of f when d is 4. Correct. So you just say 108. You put 108 divided by 4 squared. So 108 divided by 16, which is 6.75. Correct. This is how you solve this kind of question. The rest will be super easy. Super easy. So we have this kind of questions, like you're finding the inverse. For example, why you can be given an equation. Let's say it's a square. You say y is inversely proportional to x squared when x is 4, y is 7.5. Find y when x is equal to 5. This is very simple. They say y is inversely proportional to x squared. So we know y is inversely proportional to x squared. Then the next step that we need to have in our mind, if y is inversely proportional to x squared, what are we supposed to do? The next step is introducing constant k. So we say y is equal to k times 1 over x, which is y is equal to k over x squared. Then we have the values. Find k now. That's the next step. Find the value of k. We need to find the value of k when we are given the x as 4 and y is 7.5. Substitute this into a equation. So y is equal to 7.5 is equal to k divided by 4 squared. How do you get the value of k? You say k is equal to 7.5 times 4 squared. K is 7.5 times 4 squared. What do you get? 120. Now we say y is 120 over x squared. Find y when x is 5. Now input the value of x in the equation. So we say y is equal to 120 divided by 5, which is the value of x squared. 120 divided by 25. 120 divided by 25. What do you get? You get 24 over 5, which is the same as 4.8. So y is equal to 4.8. Correct. This is how you solve this kind of questions and you get your answers. 3 marks question. You get them as easy as that. They're not as hard as people say. You say another question, another example. You say y is inversely proportional to x squared. When x is 4, y is 2. They say find y when x is a half. This is simple. Y is inversely proportional to x squared. So y is inversely proportional to x squared. Then what are we supposed to do in the next? We say we introduce constant k. So y is equal to k over x squared. When x is 4, y is 2. So 2 is equal to k over 4 squared. Get k. To get k, you say k is equal to 2 times 4 squared, which is 2 times 16. K is equal to 32. Therefore, we say y is equal to 32 over x squared. Say find y when x is a half. So 32 divided by a half squared. So which is 32 divided by 1 over 4, which will be 32 times 4. What do you get in that case? Y is 128. That's the answer. Wow. You see these questions, they are very, very easy. Very, very easy. And this is my last example of today of the topic direct and inverse variation. They say a ball, so we have, say, a ball falls d meters in t seconds, but they say d is directly proportional to the square of t. Then you say the ball falls 44.1 meters in 3 seconds. Find a formula for d in terms of t. So find a formula. Find a formula for d in terms of t. This is simple. Formula for d in terms of t. So a ball falls d meters in t seconds. D is directly proportional to the square of t. So d is directly proportional to the square of t. And then you say, you just find the formula in terms of t. Introduce constant k. D is equal to kt squared. This is the formula. So, and then they say the ball falls 44.1 meter in 3 seconds. So d, so to get k, what do? 44.1, which is the time with the distance, is equal to k 3 squared. So what do you get? Divide by 3 squared, divide by 3 squared to get k. So we say k is equal to 44.1 divided by 9 to get so 44.1 divided by 9. What do you get? You get 49/10, which is 4.9. You get 4.9. Therefore, our formula will be d is equal to k, which is 4.9 t squared. This is the answer. If they want to find a formula for d in terms of t, this is what you put. D is equal to 4.9 t squared, and you get your answer. B, calculate the distance the ball fall in 2 seconds. That's it. So say, calculate the distance the ball falls in 2. This is easy now. The formula is d is equal to 4.9 t squared. The time taken is 2 seconds. So just say 4.9 times 2 squared. So 4.9 times 4. 4.9 times 4. What do you get? 19.6. 19.6 meters. Correct. That's the distance. Champion, welcome to my math class. In the next class, I'll solve many questions in the same unit of direct and inverse proportion. But I've shown you all the examples and how examiners trick this kind of question just for you to fail simple questions. But they're very simple. The unit of direct and inverse proportion is one of the most commonly asked units in your IGCSE exam. Stay connected in my next math class. I'll be taking you through the same unit and revising different kind of questions in the same unit, and I'll show you how examiners put tricks in different concepts on the same unit, and I'll show you different format of questions. So it will be easier for you to understand, you'll be able to know whether it's direct or inverse proportion, and you'll excel well in your final exam. I can't wait to see you at the top, champion. Bye-bye.